Good morning, good afternoon, good evening, everyone, depending on where you're joining from. My name is Anya Khan Iyang, and thank you for registering and making our time to attend this session. And also thank you to Analytics Vidhya for having me on this data hour session. So today, as mentioned, we will be discussing uncovering hidden insights with topic modeling and clustering in natural language processing. So I'll just go over quickly what we'll be covering. So I'll try to keep this talk at about 45 minutes so that I can leave some time for questions. So I'll start by introducing myself, which has already been done. And then we would go straight into like topic modeling, clustering. What is topic modeling? What is clustering? What are the different algorithms? How can these algorithms be applied to solve different, business use cases and different problems? And then we'll jump right into a demo. And then I would come back to cover, challenges of the project discussed in that demo, as well as possible next steps in case you want to like explore more or build on this. And then I'll take questions. So about me, my name is Anya Khan, as the host said. I have my bachelor's in computer science from the University of Uyo, Nigeria, which is where I'm originally from. And then after that, I started working as a data scientist at startups in Lagos. And I did that for about 3 years before, relocating to the US for my master's in computer science at the University of Denver. In grad school, I did research, and my research was in artificial intelligence and human robotic interaction. So I did that for 2 years. And after grad school, I resumed at Microsoft as a data scientist. So I live in Seattle, Washington right now. Yeah, so outside of work, I like to share my journey with the tech community. I have a blog I write articles on, even though I haven't published in the last couple of months because I have other things I'm working on. And just sharing my knowledge, on platforms like this. So I really love to engage with the tech community and share my knowledge.
Just a quick note, Analytics Vidhya has 100 plus free courses from beginner to advanced on topics like machine learning, generative AI, agents, etc. Complete with certification. Click the I button to explore now.
So let's get right into it. Topic modeling. What is topic modeling? So topic modeling is the process of building a model to classify text into topics or categories. So it's quite explanatory from the title. And the process for topic modeling is you first collect the documents and then you carry out pre-processing on this document. So you could clean the data, you can drop stop words, you can normalize the data, and drop maybe dirty data, missing rows, so pre-process the data, convert it into word vectors or embeddings, and then you run the topic modeling, like algorithm on it to classify the words into different topics or different categories. Topic modeling can either be word or sentence based. So word based is each individual word is classified into a topic versus sentence based that looks at an entire sentence to give a topic based on the sentence. So below in this presentation, in this slide, I have a sample sentence. So the first sentence, the hotel is very close to the airport, so she should not miss her flight tomorrow morning. However, classes resume in a week, so she has extra days to settle in. She's really excited to go back to school. If we were doing word-based topic modeling, the words highlighted in blue can fall under maybe the travel topic of vacation or something like that. And then the words highlighted in orange can fall under the education or academic topic. Now, if we're doing sentence-based topic modeling, the first sentence in entirety can fall under the travel. So we're not just looking at the keywords of the words, we're looking at the intent of the entire sentence or the topic of the entire sentence. And then the next two sentences can fall under education. There are multiple libraries, you can use for topic modeling. I personally use Python to write code, so I will be talking about libraries you can get in Python. So one very popular library or package for topic modeling is GenSim. So GenSim has the capabilities for multiple topic modeling algorithms, either latent dirichlet allocation, which classifies words based on topics by probabilistic classification. For example, there is a word, then each of the topics will have a probabilistic or probability for which that word is under each topic. And then if you want to know the topic of the word, you pick the topic with the highest probability for that word. You can also use GenSim for latent semantic analysis. So this uses dimensionality reduction to do semantic analysis, semantic similarities to classify words under topics. And then another library you can use for topic modeling is scikit-learn. So scikit-learn has accommodation for LDA algorithms as well as non-negative matrix factorization algorithms. So non-negative matrix factorizations algorithms is an algorithm that creates a matrix or a group of metrics of words and tries to match each of those words to like different values in the matrix where it's not negative. And finally, you can also use pre-trained models for topic modeling. So like we have BERT topic, we have SBERT. You can even use large language models for topic modeling, which is some of the things I highlight in like next steps for this. Yeah, so the image at the bottom again shows the process of topic modeling. So from documents, which you can also call a corpus of text or a corpus of words, you split it into different topics per document, and then you can split it by word if you want to go further. Moving on, clustering. Clustering is an unsupervised machine learning technique that is used to group data based on similar features. So the graph on the right is a sample plot of a clustering being done. So in this, you notice that one, there are distinct groups of data points, which we call clusters, and each cluster is highlighted in a different color. So you can, understand, so you can separate them rather. There are two types of clustering algorithms. The first being, so there are two types of clustering algorithms. They can be split between partitioning clustering algorithms and hierarchical clustering algorithms. Partitioning clustering algorithms are algorithms that the method of clustering is by finding a centroid and then assigning different data points to each of these clusters based on the distance to each centroid. Whereas hierarchical clustering algorithms are algorithms that follow a tree-based mode. So it picks the first data point and then it picks the next data point, and based on the similarity or distance between those two data points, it assigns it to clusters. So it's like a tree-based and it goes quite long. It's like depth-based. Then you can also classify clustering algorithms as hard versus soft. Hard clustering algorithms are algorithms that assign each data point to a unique cluster. So you don't have overlaps with hard clustering algorithms. A data point either belongs to cluster X or cluster Y. Whereas soft clustering algorithms allows for overlaps. So, I mentioned earlier with the LDA with GenSim, that's a soft clustering algorithm because each word or each sentence is assigned to a cluster with different probabilities. So it's not a unique one-to-one mapping. It's one word can have multiple clusters with different probabilities, which is good because sometimes, especially when you're looking at sentence-based, it isn't always unique. So it isn't always, okay, one sentence is entirely about something. It can be about two things because that's the thing with language. Yeah, so clustering can be run on word vectors and embeddings for topic modeling. And in this demo, the demo I would be going ahead to shortly, we will be using SBERT for sentence embedding. As I said, there are multiple clustering algorithms, but I've decided to highlight two. So the first one being k-means clustering. This is a very popular, fast, not computationally expensive clustering algorithm. It's what we'd also be using in the demo today. It is a partitioning-based algorithm. That is, you pick a k number of clusters, and then the algorithm creates centroids for these clusters and assigns different data points to these clusters based on the distance to the centroids. It's also a hard clustering algorithm, so we won't have overlaps or, different topics in a sentence. And it can cluster documents or sentences into topics. So that's what we're using for our sentence-based clustering for topic modeling in this demo. The next clustering algorithm I want to just highlight is the agglomerative clustering. unlike the K-means clustering, which is a partitioning-based clustering, this is a hierarchical clustering algorithm that follows a tree-like format and clusters different data points based on distance from the first point. It's one of the benefits of this sort of clustering algorithm is you don't need to define the cluster count because that's one of the drawbacks of the K-means clustering. In K-means clustering, you're passing in the number of clusters you desire, which is K. So with agglomerative, you don't have to pass that. It automatically defines the number of clusters it thinks the data should have based on how the data looks. And agglomerative can cluster words into topics. So quickly we'll go to the applications of topic modeling and clustering. So for topic modeling, you can use this in industry for intent classification. So if you're curious to see, what are users doing on my site? What are users doing on like social media? Topic modeling is a good algorithm to run to see that. You can also use it for text summaries and for like customer reviews, retrospectives. If you get feedback, it's a good way to see, okay, what are the highlights or what are the lowlights from my product. For clustering, you can use it for customer and market segmentation. So if you have users or user profiles, you can create different clusters of users and even send them multiple campaigns, multiple, marketing emails based on whatever goals you have. You can also use clustering for image segmentation and medical imaging. And finally, for topic modeling, which we'll be doing in this case. So quickly, I would go to the demo. It's a quick demo that we have. Okay, so it's on Google Colab and I could share the link later after I learn. Okay, so I'll walk through the code in this notebook. So in this notebook, I'm reading in a dataset from Kaggle, and it's a news topic classification dataset. So I'm running a sentence embedding on the titles or the headlines of the news, and then I'm doing topic modeling on that, plotting the clusters, finding representative sentences for each cluster. So we start by installing the necessary libraries we need. So the first one being the sentence transformer that is expert, which we would use for the embedding, for the sentence embedding, for the top clustering, and then NLTK, which we use to, clean the data, remove stop words, and then the Kaggle libraries because I'm calling the data from Kaggle and I'm using the API to read the data set. Yeah, so as I said, we download stop words, we just look at the stop words, and then I log into my Kaggle account, which I've already set up with my credentials, and I'm able to read the data. So this is the link to the data set I would be using. And so we have the data frame here. So it's a two-field data set. It contains a text and a label because the data set was initially created for a supervised learning, algorithm. I don't need the labels because clustering is an unsupervised machine learning algorithm, but I'll be reading only the text, and we can see maybe what the first one looks like. Yeah, so I printed the first sentence here, but I can print it again. So let's see text. So to see what the first one looks like fully. Yeah, so it says US lacks golden touch. So it's the headline of what the news reads. So I also create my model. So we're using a sentence transformer, and in this case we're using SBET, which we imported, which we got here. So sentence transformer. You first have to select the version of the model you want to use. There's different versions of the model or API to call, but in this case, I'm using the mini LLM L6v2 because it's good, or it's very good for like sentences and short paragraphs, and it also accounts for different languages. So this is something to take a note. If your data set is not necessarily in English, this is a good API or model to look at because it can also, create embeddings of different languages. So I create a sentence transformer model, which I'll be calling on my text to create the embeddings. And currently my text is about 120,000. But because of capacity and for this demo, I decided to take 5% of that. So I took a random 5% sample, which in this case is 6,000. So a random 5% sample of the data, and then I encode this. So this takes quite a while to do the encoding, but it's basically the process of turning the text sentences into an embedding vector, so a tensor array, and each sentence has a tensor array of numbers assigned to it, and and it's based on these numbers assigned to it that the topic modeling is done, because it calculates the similarity or the similarity or the distance between these embedding vectors for each of the sentences. And then I go ahead to write a function for clustering the text. And my default number of clusters is 8, but I would, as we will see in subsequent code, there's a formula or a process of finding the ideal number of clusters, because that's a concern for using k-means. How do I choose the right number of k? You don't want to pick a k that is overfitting or is underfitting. So how do I choose the right number of k? So that the next function covers that, and I would talk about it as well. But for this function I'm writing, I just set the default number as 8. So it takes in the word embeddings, and then I'm also taking in the raw text and then the number of clusters. What this function does, the cluster attributes function, it clusters the different, the sentences in the embeddings based on the number of clusters. So we take in first the embedded couples, the original text, and the number of desired clusters, and we return a tensor array of the cluster labels for each data point, that's each sentence or each headline in this case, and then the representative sentence. So a representative sentence is a way of labeling the clusters, because when you do clustering, the results are returned as integers. So you have line 1 is cluster 1, line 2 is cluster 7, line 3 is cluster 6, and that's not very actionable. What is cluster 7? How do I know what is cluster 7? How does that work? So in something like topic modeling, creating representative sentences, which is like a representation of each cluster, is a good way to go. So you can look at the representative sentence and say, okay, this cluster is about health. This cluster is about sports. This cluster is about baseball, things like that. So that's what we're doing here. So because k-means doesn't support cosine similarity, which is what we're using to find the similarities between each of the corpus embeddings, we first have to normalize the embeddings, and then we now build like a clustering model on this data. So here we've created the clustering model, and then we fit this model on our normalized embeddings. And this gives us the labels, as I said, which are numbers. Going on to do the representative sentences, you can set this number to any number. You can decide to have 5 representative sentences per cluster, but sometimes that confuses me. So I decided to have just 1 representative sentence per cluster, so that I can just read that sentence and then I know what the cluster is about. So for each of the clusters, I'm finding the centroid, and then I'm finding the similarities between each of the points in the cluster and the centroid. And then the closest point to the centroid of that cluster, I take the sentence as the representative sentence. So each cluster has a centroid, which is the middle point of the centroid. So we find the closest data point to that middle point, and then we get the text version of that data point, and that's what we take as the representative sentence, so that we can understand better about the cluster, because the centroid of the cluster is the best representation of a cluster. Moving on. So I mentioned, how do I know the number of k? How do I know what to set my k at? How do I find my k? There are different ways to do this, but one that I like to do personally is called the elbow method. So the elbow method graphs the different values of k on the embeddings to see which value of k makes the most difference or is the most optimal. I set my max at 10 here, But you can set it up to 30, 50, 100, depends on how large your data is, how much compute you have, and just how much time. You can go as far as you want. And so what it does is it takes each of the data points, it takes each of the data points in the cluster and does the clustering and says, okay, if I increase the K, does it make any difference in the clustering for it to be more similar? And you plot the graph to see. So for here, I set the max K as 10, and we can see how the optimality for, different values of K on our current data looks. So this value of K can actually change because I'm sampling 5% of my entire data set for this demo, right? So each time there is a run, it's not exactly the same row that I picked because it's a random sample. So based on the random sample that I currently have, 8 is an optimal K to use for the clustering. And so I picked that up and I passed my number of clusters as 8. And I return the cluster labels and then representative sentences from my cluster attributes function that we, discussed above. And then I'm just printing like top 10 sentences to see what it looks like. So we've done the clustering, and then the first sentence is US lacks golden touch, big class 8, New York something. And then it says cluster 6. And then the second one says cluster 5, cluster 5, cluster 4. So this is what I said, that the labels are just integers and it's not actionable. It's not easy for a human being to interpret what that means. It's not easy for a human being to understand what is cluster 4, what is cluster 5, what's the difference between both. So that's where representative sentences come into play. And so in the next cell, I'm printing each cluster and their corresponding representative sentences. So I'm going to go over that. So for cluster 0, the representative sentence is global warming ever. So we can see that this is about like environment, or, climate change. So this is the cluster representative sentence. So we can see the first topic is about environmental management or environmental science. So that's what cluster 1 is about. And then the second one is about the conflict between Israel and Palestine. So this is probably about politics or foreign policy or conflict or war. And then the third one, we see it's about like hurricanes. So we can see like natural disaster, or it's also concerning sports. So it's in between natural disaster and sports. The fourth one, I think this is about finance. So I think stocks, stocks are rising, stocks are falling. So this is a good one. And then we see tech. This is about tech businesses, tech companies. Then the next one is probably about business. So we're talking of buying a site or buying it. So it's probably about business. And then the last but one is I think it's about sports as well, golf. And then so this is what the representative sentences look like for each of the clusters. And now another thing with clustering is you can easily visualize it. It's easy for you to visualize. That's one of the high points of clustering. You have these random data points. You want to be able to visualize how they connect to each other. So I'm going to use Matplotlib to do this. So I have it as a 2-dimensional plot so that you can easily see it. And as you can see, we have 8 clusters here. So cluster 0, 1, 2, 3, 4, 5, 6, 7. So we see that each cluster has a different color. So cluster 0 is here right here in the center. We see a lot of blue. Obviously, there are outliers, but that's one of the disadvantages of hard clustering, because something here, this blue here, might be actually blue and orange, but it's assigned to blue because it's a hard clustering algorithm and there are no overlaps. But so we see cluster 0 as the blue in the center. Cluster 1 is right here, the orange. Cluster 2 is the green here. Cluster 3 is here. Cluster 4 is the purple here. Cluster 5 is the brown here. Cluster 6 is the pink here. And cluster 7 is the gray here. So this is also a very good way to visualize if you're using clustering for like topic modeling And you can now map this to your different representative sentences. You can also do more analysis like, okay, how many sentences fall within each topic? How many sentences fall within each topic? What are the topics here? If you're building a product that, for example, if you have a chatbot or something and you get feedback from your users, you can map, okay, what are the topics people are talking about in my chatbot? What are the topics they're asking for help? And how do these topics correlate with like thumbs up, thumbs down? Are they impressed with the response we're giving? Are they not impressed? Is a good way to see how you can, take feedback from text and improve your product. So that's the end of this demo. I will share the link to this notebook after so you can run it on your own. You can try with a different data sets. You can play around with different like case, different samplings. So I will go back quickly to the presentation. So I think I would finish soon so that we can take questions. Yeah, so next next thing I would like to discuss following the demo is challenges. I've already mentioned some of them while going through the demo, but some of the challenges of like using clustering for topic modeling is choosing the right number of clusters, especially if you're working with a partitioning clustering algorithm. How do you know the right number of clusters? I know that there are different methods to pick the right number of clusters, but that's added, computation that you have to spend to run that first to choose the optimal K before you begin clustering. So it's one of the drawbacks of using clustering for topic modeling. As I also mentioned in the demo, like when we looked at the clustering and we saw some blue within pink and orange, sometimes clustering is not the best. Some clustering algorithms are not the best at handling outliers and vague and overlapping clusters, especially when you're doing something like sentence-based clustering. The sentence is not just about one topic all the time. So if you have a lot of sentences like that and they are about multiple topics, a hard clustering algorithm might struggle to do that because it's used to assigning unique clusters to each topic or to each sentence or to each word. Another challenge is accurately labeling cluster names and topics. So we have the representative sentences, which I walked through in the demo, but you saw that there still had to be that factor, explaining the representative sentence. You still need an added layer, either a human or build a model for that. So what is this sentence about? And I think capacity constraints is another challenge of clustering. Sometimes it can get slow, which is why I'm sampling 5% for this demo so that we don't have to wait hours for it to run. So these are some of the challenges of using clustering for topic modeling. Possible next steps. So as I said, I'm using clustering to, do topic modeling, but the age of AI right now, large language models or LLMs are one of the most popular, algorithms. So possible next step that if you want to build on this, or if you're curious and want to explore more about, you can do is actually using LLMs to label the cluster names. So as we do the clustering, we get the representative sentences for each of the clusters. You can build an LLM model on text data to be able to say, okay, what is this sentence about? Give me one word to describe this sentence. So these are prompts you can give to the LLM to get exact cluster names. Or give a prompt and say, oh, give me 2 words that describe this sentence. Or what is the topic in this sentence? What is the intent of this sentence? So that's a possible next step you can do on top of that clustering. Or you can even use, large language models to do end-to-end topic modeling. So you're giving the LLM a corpus of text documents and you're saying, classify this into 10 topics or classify this into 5 topics or what are the major topics in this document. So these are possible next steps you can explore apart from using just clustering for, topic modeling.